comforting to think about climate in terms of averages. I mean, that's an easy way to think about things. The average temperature on this date in Omaha is 32 degrees Fahrenheit, or the average rainfall on this date in southern Indiana is 207 inch, or whatever. But really, climate is so much more than just averages. I mean, there's clear year-to-year variability in climate. You know, like last year, the winter was very mild, but so far this year, the winter has been horrible here. And we could quantify that and so on. That's year-to-year variability. The jargon word there is interannual variability. But, you know, and that's important. Year-to-year variability is an important part of our experience of weather, and for that matter, so are trends. You know, yes, there's a lot of year-to-year variability in the temperatures here, but from the point of view of a course with words like climate change in the title, we're also talking about how temperature is changing with respect to time. Both of those are important ways that we have to start thinking about climate too, and have to have ways to quantify, and have to have ways to have statistical tests of the significance. Of course, the IPCC weighs in on what all this means. And the IPCC says that the climate change refers to, that this jargon term here, let's be clear, climate change refers to a change in the state of the climate that can be identified, typically through statistical testing, by changes in the mean or by changes in the variability of properties. We could be changing, increasing the variability and seeing more warm events or more cold events or something like that. And to be clear, it's called climate change regardless of why it happened, whether that is because of natural climate variability, like volcanoes and changes in the Earth's orbit and changes in solar output and so on, or whether it's anthropogenic, as in originating from human activity. Whether it, like it could be greenhouse gases, that could be land use changes, that could be changes in ozone concentration or whatever. But clearly in this course we're going to focus on one particular source of anthropogenic climate change, and of course that's going to be this business of the greenhouse effect and the enhanced greenhouse effect. Let's be clear about our jargon here real quick here. The greenhouse effect, as you learned in, say, ATS105 or ATS113, is a very natural and important part of Earth's radiation budget. In fact, life would not be possible on Earth without the greenhouse effect. Earth is too far from the sun to be in the Goldilocks zone where water exists as a liquid and so on. It's only because of the presence of greenhouse gases in the Earth's atmosphere, most notably carbon dioxide, that the planet stays as warm as it does and we are able to, say, live here. On the other hand, of course, there's the anthropogenic increase in greenhouse gas concentrations that has enhanced the greenhouse effect, where we have made the planet warmer. Now, in coming lectures and coming modules, we're going to pick this apart in great detail. And we're going to really talk about the physics of how the greenhouse effect works and how we've enhanced it. We're going to talk about what we can do about it. But for right now, for the first day of lectures that are actually about content from the book, I think you understand. This is that little goose that we have given the climate change, the climate system by enhancing the greenhouse effect, which of course has led to global warming. Okay? Now, I'm saying of course, but we need to understand that. The connection here needs to be very clear, and we're going to be doing that over the whole semester. How exactly has enhancing the greenhouse effect by adding these greenhouse gases resulted in global warming? Where, how much, what parts of the climate system, and so on. And in the process of doing it, we're going to be building all kinds of conceptual models like this one here, where you can see the flow of shortwave and longwave radiation through the Earth atmosphere system. You could see the importance of things like clouds and aerosols and ozone and greenhouse gases and, oh my goodness, there's so much going on. Dr. Shruggy, we're not really going to learn all this. Oh, this is going to be such an old friend by the time we get done with this class. But for right now, I'm just introducing the idea that we have this conceptual model, this idea of how energy flows through the system, which will be translated into numerical models of like the climate system that we will be able to integrate forward and get projections forward of what the climate is going to do. Now, before we move on to a fourth part of this lecture, let's real quick answer a couple more quick questions about all of this. The term climate change only refers to changes in the climate system caused by human activity. True or false? How do we use that word climate change? Make a choice from those two options and get some feedback before you move on to question 6.